So let's take a look at the graph of our function and see what adjusting a and b does to our graph. So first off, let's mess around with a right now. Notice there is a horizontal asymptote and it's around 1. Look at what happens if we increase a. Now it's hard to see because of b, but that's actually going to increase our horizontal asymptote. So what we'll do is we'll adjust b and see what happens. Notice the greater I make b, the quicker it gets up to that horizontal asymptote. In fact, if we make b up to 10, it gets up to that horizontal asymptote, which is set at 2.5 very quickly, but then completely levels off. As b gets smaller, that increase becomes less gradual, but it still has a horizontal asymptote at 2.5. Notice, no matter what a and b were set at on our sliders, the function was always increasing and it was always concave down, which is what we saw in parts A through C with our analysis. Now what we are seeing is the larger b gets, the faster it increases. So as we're making b larger, it's not only making our first derivative larger, it's making our second derivative larger. And we're seeing that in the graph, and we saw that before when we calculated our first and second derivative. So that just gives us a little bit of analysis of what happens as we adjust a and b for this family of functions.